Hey and welcome! Today it's again chemistry and the goal is to make sodium sulfide. So I've printed it out here and I wanted to make this chemical sodium sulfide for quite a while now. It's one of these weird chemicals that have extraordinary property. I mean, it's soluble in water, quite a lot actually, and it is a sulfide. So once you dissolve this in water, you're getting sulfide ions and HS ions. Both of them are in kind of a balance depending on the pH. And of course, if the pH gets too low, you will get hydrogen sulfide and the sulfur will bubble out as a gas, hydrogen sulfide. And you get the corresponding sodium salt, depending on the acid. To produce this, there are various methods involving sodium hydroxide and hydrogen sulfide bubbling through it, but I want to focus on this method today. So sodium sulfate, which is a classic eBay, and carbon fused together at high temperature, called carbothermic reduction. So that's what I want to do. And this stuff stinks, and even with the air it starts stinking. I'm just looking for where it is. I can't find it in the text. I've only printed one page. So for the preparation, I want to make 1 mole. So we have 78 gram per mole. Mole is 1. I want to make 1 mole. So I have 78 grams, which is my goal to make. Anhydrous, of course. I hope there won't get any water in, because then it will stink. I try to exclude the water, so I'm using 142 gram of sodium sulfate, water-free, which is very important. It's over here. It says water-free right there. And 24 grams of carbon to fulfill this equation here. This would be the exact amount, but probably a lot of this carbon won't react, so I'm going to use an excess of 40 grams in total. So this thing actually has a pretty high melting point, so it won't melt in the synthesis, because I'm not going over 1000 C, and it hopefully stays away from water, because if it comes to contact with water and carbon dioxide, it usually starts to stink by producing hydrogen sulfide. But as long as there's only carbon, oxygen, sodium and sulfur in, and no hydrogen, no way for hydrogen sulfide to be created. Well, that's all about there. So I have pointed everything down. So now to the synthesis. Well, of course it needs a crucible, and I'm going to use this alumina crucible. So nice about this thing is it's very heat resistant, and it's not being reacted away as my graphite crucibles. So wait just a second. Here I have a graphite crucible, and I don't know how well you can see it, but it has suffered a lot from being just one time in the furnace. You can really see how much the wall thinned out here on the bottom, and it really gets eaten away in some parts. So that's why I'm going to use alumina. I mean, by this reduction here, yeah, it would participate in the reaction and therefore being eaten away even quicker. So here, alumina furnace, crucible, and my good old electric furnace. Well, it has suffered, and you've probably know it if you've been here for long enough on this channel. It has several cracks, which probably due to my stupidity and not the problem of the furnace. I tried to repair it, but the stuff I put into repair didn't stick to the surface, and so it just started to fall down. So today I used the screwdriver and manually removed all of this stuff. But the furnace itself, the cracks are just minor. I should just have left them where they are and did nothing, because that was obviously a bad idea to put cement on there. I mean, I had a layer this thick and it just started falling off. So this will be the furnace for this reaction. So let's make the mixture. Get this on here and a bit closer to the sodium sulfate. Get this on 0 grams. So I want 142. 42, oh that's fortunate. 72, just a 70 more to go. 102, it doesn't need to be that exact, but I don't want to do the calculation again, that's basically it. And if it's less, it's okay. If it's more, it's a bit stupid, so. Fair enough, 143. And it's filling only a bit on the bottom of the crucible. So that's done. Reset this. So here I have various types of carbon. This is the more coarse stuff of charcoal, and it will be used to seal the top against oxygen. And this is the fine stuff, which will be used for the reaction. So I need 40 grams of this. Eight. You see the crucible is all dirtying up, but because that's alumina and this is carbon, I'm using this crucible. If I did this reaction, I just put it in empty into the furnace at around 800 C and it will all burn away. So all these black stains, they will remove themselves. Why it's still at 7? Ha! It jumped to 17 now. The scale is a bit stupid at these level ranges. 24, 30, 40. Like this should be sufficient. This carbon is actually a nightmare. It stains everything black. I really don't like it. Now it says 36. It's kind of odd. So let's start actually mixing this. It starts to give up carbon fumes, so it's probably time to seal up the chemicals first. I'm going to do that now. So I got everything stirred up. It's a bit of a mess, but a convenient way is just put some foil over top and shake it. And you see it's kind of grayish now. It's fairly well mixed. There's just one more thing to do before we can start putting this in the furnace, and this is putting some coal on top. So why is this any useful? Well, upon completion of reaction and following cool down, oxygen will get in and probably oxidize some of the sulfide back to sulfate, and having some coal over the top prevents this quite well. The crucible itself, it will self-clean. It will be clean if we take it out, except for this in the middle. Quite dark outside, but the furnace is set up, so time to program the furnace and then go. So first go to 400 C at a rate of 400, then go to 1000 and hold it for, I would say, an hour. So we're an hour at 1000 C. Go to 400 in 1 hour, and then to full power up to 1000. I guess that's actually a little bit long. Could probably do less, but it really depends on the weather. Hope it doesn't start raining. Well, there you see it. Show it again once it's hot. New day, new try. Currently at 841 degrees Celsius, vigorously boiling inside, all the CO2 being liberated. You see it's day now. Last time it started raining, so I had to stop the whole experiment. But this time it's nice and clear weather, and I start smelling sulfur dioxide, which means that something in there is probably oxidizing. I have a gas cleaning setup. Probably time to use it soon. The furnace is fighting a fierce battle right now, trying to reach 1000. Is at 990. I think it makes it. Let's give it a little close up. You can't see well, but it's certainly hot. Turn the scrubber off for a sec, turning back on now. As you see, it caught some sulfur. And there it is, the remainings from yesterday furnace operation. Literally unchanged from the furnace. You see, this is a solid blob. Nothing comes out, molten. There's good news and there's bad news. The bad news is that there is no more protective charcoal, which means that there was an oxidizing environment, and it maybe oxidized our product, sodium sulfide, back to sulfate while cooling down, or by being heated up. Because all the charcoal is gone, that's the reason why the smelling of sulfur hydrogen suddenly stopped. The sulfur hydrogen simply burned in the furnace to sulfur dioxide. That's because there was no longer a reducing atmosphere. Why did the hydrogen sulfide, was sulfur hydrogen? I don't know, be created in the first place? Probably ambient water, because in this there was no hydrogen. I was quite sure to dry up everything. Well, it's good that the sulfur hydrogen production stopped, or hydrogen sulfide, I still don't know. But I had a scrubber, so it was good, but not really necessary. Probably I should have taken this out earlier. I mean, it definitely worked. There are all these little gas holes here, which means that carbon dioxide was produced. Let's try to find it out. So I definitely need to dissolve this. That's what I'm going to do now. And I'm using 500 milliliters of water, and then doing a quick pH test. If it's basic, we might have product, but it might have also other reasons. But if it's not basic, we definitely failed. So let's give this a try. Like this. Please don't sting, please don't sting. A little bubbling, not too intense. Please don't start bubbling. If there's a sulfur hydrogen leak now, I'm probably fucked. Let's give this a test. Oh no. I mean, probably nothing dissolved yet, so maybe just waiting a bit, but looking at this, it's horrific. I mean, that's it's neutral. That's not good. Let's wait a bit. Really, this calcinated stuff is not dissolving the way it should. It takes an eternity. But maybe that explains why it was neutral at the beginning. Maybe it's basic now. Oh yeah. Deeply purple. Seems as our experiment probably worked. I mean, this is purple, this is close to pH like 13 or 14, and this is what it has to be. So what other possibilities for being basic could there be? First of all, sodium sulfide isn't one. Then there's the ash from the charcoal, which is carbonates and oxide. Might be. And to reach this purple color, you do not really need that much of basic substance. Probably a few grams are enough, probably even milligrams. So this is no indication yet, but we are on the right way. It's not neutral anymore. So there's probably some sulfide in there, and I already see this paper getting bleached. We're really on a good way, because that's unusual. The pH paper is getting bleached. Next up is the stink test, where I use a little bit of this and mix it with acid, and it should stink horrific. Yeah, there's certainly yellow, and that's sodium sulfide, and I smell it. I smell of rotten eggs, and the stuff is so calcinated, I had to come with a drill. Really, a day of soaking, nothing. But a drill. A goddamn drill. Well, I hope I can save this crucible at least. So, finally, time for the conclusion. This is the stuff that is left of soaking the crucible for one day. Not much dissolved, it's highly basic and smells bad. And from the drilling in the crucible here, that's what I probably love about chemistry, ending up drilling my crucibles. The crucible will probably survive. I'll figure a way out and retrieving my product. There was a lot of yellow and white solid. Probably got even a good yield. Maybe I'll tell you about it in the next video. But some of it dissolved here, it smells bad, and also most of the coal went in here. So I'm going to add hydrogen peroxide and find out if there is any sulfide. So I already know it, but this is just a confirmation run. It should precipitate sulfur, and at least for a bit, and finally convert it to sulfuric acid. So let's give this a try. Things are difficult if you have just two hands. You see that? It's certainly went a bit yellow in there. Oh no, it stings. I know these things have acid in them. Phosphoric. Unfortunate. But it's yellow now. Sulfur. Oh, that's not good. Oh fuck. You see that? Yellow. It wasn't like this before. If I shine it directly on top, you only see it without the camera. But from this side, it's also visible on camera. Smells like sulfur dioxide now. A little bit. This got freaking hot. I don't know why, but I brought the confirmation. It definitely is hydrogen, sodium sulfide was in there, only a tiny bit, I mean, that's just a small amount of sulfur, but not much dissolved in there anyway. It was really only a bit, most of it calcinated in the bottom of the crucible, probably not even 0.1% of it dissolved in here. It's only a bit of coal floating around, but that's not dissolved, that's just emulsion. Yeah, that will be it. And I don't think I'm going to show the process of painfully cleaning the crucible and retrieving the product, because you know, it worked. I can't really show a synthesis without showing the product. There are some yellow bits and pieces. Difficult to see on camera. But why is there yellow at all? Well, there are some polysulfides of sodium that formed, and it stinks. And I'm doing this inside and I'm already regretting it. But that's the product. I have to drill all of this out, because it somehow won't dissolve that easily. Probably sintered and calcinated together, and it stinks. And I think the yield is good, because it has been in here for just a few seconds and it already stinks like hell. And it definitely works. It's not dangerous, but it's annoying. Annoying stink. But that's the product. It worked very good. And if I get this dissolved into water, or some other way getting this just out, I'll have it for the next synthesis. So a lot of things gone wrong. At the first attempt it started to rain onto the furnace. So I was in the middle of the synthesis, and here you see actually where the crucible was, and it just started to rain and I had to rush everything inside. It was just a mess. Synthesis didn't finish, so at the second attempt it started stinking and I thought, oh my god, that's hydrogen sulfide emission. And I thought, well, it's over now, but it died down because the atmosphere got oxidizing. And then I thought, well, okay, now the atmosphere is oxidizing and my product gets destroyed, but luckily this thing calcinates. Well, there is a drawback, I won't get it out. So you can probably do this without the protective charcoal and avoid the stink by a lot. I mean, sulfur dioxide is better than hydrogen sulfide. But it also means that you won't get this out really good. I mean, you won't get it out in both ways. So that's actually an improvement. Because it sort of melts together and sinters and just forms a solid block that hardly dissolves. I probably have to cook this, or... well, I'll find out. But here it is. I'm proud of it. Synthesis that worked, and see you next time.